Okay, let's give you guys some more practice. So here, differentiate this. Find the derivative of the inverse cos of x. But before you do, have a look at this graph here. This is your normal standard y equals cos of x. We are interested in the inverse function. So we are interested in this graph here. So starting with this normal graph here, we need to reflect it in order to obtain our inverse function. So now I'm just gonna reflect it. So hang on. So let me reflect it. So this is a reflection here along the y equals x line. So this is our inverse function. But at the moment, it's not a function because if you draw a vertical line here, you're going to get at least two solutions. So at the moment, this is not a function. So we can cast it into a function by just concentrating on this bit here. Let's just restrict it to this area only. Now we've got ourselves a function, because if you draw a vertical line here, you've only got one solution. Draw it here, you've only got one solution. You could argue that you could create this, you could restrict it to this area here, but let's keep it simple. Let's keep it positive. So down here is so this is your x here. This is your y here, and let's just keep it simple, keep it positive. So let's just concentrate on, well, let's restrict it to this area here. So yeah, so the domain here would be -1 and +1. So restrict it to this area, you have yourself a function. So when someone talk of the inverse cos of x, in your mind you should be visualizing this graph here, where the domain here is -1 and +1 here. Domain here, -1, +1, and the range here, the highest point is pi, the lowest point is 0. So yeah, so when someone talk of a function, the inverse cos of x, then picture this in your mind. Okay. Well, anyway, find the derivative here. So hang on, find the derivative. Hang on. Oops. Let me. Yeah. So find the derivative here. So press pause and have a go. Okay. So to do this here, starting from here, cos both sides. That will take you to here, and then now visualize as this. You've got well, this here is a function of x, so you've got to use implicit differentiation. So differentiate both sides. That differentiate cos of y, that will give you this here. But because y is a function of x, then you've got to stick in this y prime here, and then differentiate this. This will then give you 1. So at the moment you've got one bubble multiplying another bubble here. You are interested in this one, so get rid of this bubble here. So divide both sides by minus sine of y. That will then give you this. Okay, so this here is your final solution here. But then you don't want the answer in terms of y here. So hang on. So you don't want the answer in terms of y. Look. So originally we started with this. Cos both sides. That will then give us this. Now at the moment, the answer here, you don't want this in terms of y. But then you've got, well, the next step here is to use that cunning step. Is to use that cunning move. Translate this cos of y into sine of y. Okay, so from here, translate this. So use a triangle, use a right angle triangle here. Okay, yeah, translate this into, somehow translate cos of y into sine of y here. So cos of y, let's just say the angle here is y. Cos of y will be this. Cos of y will be this. So cos of y equals x. So how would I create an x? Well, let's just call this x, and then call the hypotenuse here 1. Okay, so if you think about it from trigonometry, looking at this diagram here, you can see that cos of y equals x, which is the adjacent, over the hypotenuse, which is the same as this. So you see this is exactly the same as this. Okay. Well, anyway, so from here, translate it to this diagram, and then from this diagram we can then translate it to sine of y, because sine of y, well, what's sine of y? Sine of y would be this over this. over the hypotenuse. So sine of y, hang on, let me get rid of this. So sine of y, looking at this diagram, sine of y equals this length here. What's this length here? Well, this length here, using Pythagoras, it would be root 1 squared take away x squared here. This length here will be given by this. So it's going to be this divided by this. Well, the hypotenuse is 1, so it's just going to be this. So sine y equals this, 1 minus x squared. You see, from here we translated it to sine of y. So now we can put this into here. Okay, so that would then give us this. So so y prime. So basically, all that we've done here is we are putting this into here. Okay, so y prime equals this here, and don't forget this thing here is only valid within this domain here, because originally arccos is the domain for arccos is this -1 and 1. The domain is only in this region here. So your answer, the domain of your answer, is only in that region as well. Okay, so overall overall y prime equals this. Okay.